Hi students, welcome back. We're going to continue looking at proportional relationships, and today we're going to be talking about a very specific type of proportional relationship called scale. And so we're going to talk about scale drawings and scale models and what a scale is. Now you're actually familiar with scale. You've seen and used scale for years. You probably just didn't know about it. So when you have an object that exists in real life and you create a replica of that or a model, that is called a scale model. And a scale model is three-dimensional and it looks just like the actual object. It is just smaller in size. So a lot of you might have scale models of airplanes or of army trucks or of all kinds of different things that exist. So this would be a miniature replica. A lot of times souvenirs are scale models of like the Eiffel Tower or the Statue of Liberty. So that would be three-dimensional, something you could hold in your hand. We're also used to scale drawings. So a drawing would be two-dimensional. It's flat on paper. And so this would be what we use when we look at maps in social studies, and it can actually tell us how far things are, even though we've shrunk down the map onto a piece of paper or onto our phone. But it's showing us the actual distance between something in real life. Sometimes scale drawings are also used to create a realistic image of something. So pictures are an example of a scale drawing where we're looking at you and your actual self shrunk down to fit on a picture that we can then hang on the wall. If you're going to be an architect or an engineer, you would be making scale drawings of blueprints. Before we can build the building, we first draw it out on paper using scale, and then we would, after it's on paper, we would make a model, a three-dimensional replica of it, and then once we know it's structurally sound, then we would go and actually build the building. So what is scale exactly? Scale is a ratio. That's what our whole chapter has been about. Ratios that compare the size, dimensions means size, in a drawing or in a model to the dimensions of the actual object. So a lot of times scale will take something really big and we'll shrink it down so that it could fit on a piece of paper or it could fit on a table. But sometimes scale works the other way. Sometimes scale takes something that's so teeny tiny that we wouldn't even be able to see it, and it blows it up really big. Think about what a microscope does. So in science, we use a microscope to see something so tiny, and then we enlarge it so that we can see all of its parts up close. So scales use sometimes the same units, sometimes different units. And so we're going to be looking at setting up those ratios to find scale today. So here's our first example that we're looking at. And so what we have is we have a microscope. So think about the way a microscope works. It takes something small and makes it bigger. And this is a 1,000 to 1 microscope. So that's our ratio, 1,000 to 1. Now, when I'm writing my ratio, I also like to write words down that are going to help me. So when I'm using a microscope, I'm looking at something that in real life is really, really, really small. So the actual object is going to be the 1 because it's tiny. And the microscope increases the size of the object, and so that when I'm looking at it in the microscope, the view through the microscope makes the object look really big. So we're looking at something really small like an amoeba, and in the microscope it appears, so appears tells me that's what I'm seeing when I look in the microscope, it appears to be 8 millimeters. So because this is what I'm seeing in the microscope, that would go in the numerator. This is what I see when I look in the microscope. And I want to find the actual length. So I'd be solving for x. Now this is really important because our scale did not give us units. See, there's no units listed here. So if they don't tell you units, then that means we're using the same units for both the actual object and the microscope view. So now what we're going to do is cross products. 1 times 8 is 8. 1,000 times x is 1,000x. We're going to solve for x by dividing by 1,000. And we get x equals, we want 8 in the thousandths place, so tenths, hundredths, thousandths place, and don't forget to label your units. So 0.008 millimeters or 8 thousandths of a millimeter. Okay, let's try another one. This time we're going to actually find the scale. So this tells us that a model of a 40-foot bridge is 12 inches, and we want to know what is the scale. So the scale is the ratio in simplest form. So what it's asking me to find is the ratio in simplest form. So I'm looking at my model, and the actual bridge is 40 feet. In the model, the bridge is 12 inches. So what we would do is we would simplify into simplest terms. So 40 and 12 are both divisible by 4. So 10 feet in real life is represented by 3 inches in our model. So this would be simplest form, scale. Now sometimes you'll see that they want the scale in the unit rate. So they would want to know what 1 inch represents. It's okay to just leave it in this form, but if it asked for scale factor means the unit rate. So we would want to simplify this even further, and we would say that 3 1/3 feet is representing 1 inch. And remember, unit rate is where you want that bottom number to be a 1. So in order to get that, I divided by 3. So we are okay just leaving it as scale, but you might see the word scale factor, and that's when we're simplifying even further down to the unit rate. All right, let's look at one more example. So it says we have a model of a 24-foot bridge, and it's using a scale of 4 to 2. Now, these are the magic words. As soon as it tells you the scale, you immediately write that down. That is always the first ratio that you write down. And so we know that inches is the size of the model, and feet is the size of the real bridge. So then we keep reading, and it tells us the real bridge is 24 feet. So inches goes across from inches, feet goes across from feet. So 24 feet would go in our denominator, and we're going to solve for, okay, well, how tall should the model of our bridge be? So we're going to use our cross products. 2 times x is 2x. 4 times 24 is 96. We're going to divide by 2, and we get x equals, oops, I forgot my equal sign, 48, and then don't forget our units, inches. So we're going to build a bridge, a model of a bridge that's 48 inches long. So we're going to practice some scale problems. Again, the most important part, I want to emphasize this. As soon as you see the word scale, you write that down. Then you're going to have another number. You just need to figure out where the other number goes, and then you solve your proportion.